How does this system look different than the last systems that we talked about?
There's 3 equations.
There's 3 equations. Is that it?
Whatever Z.
So there's 3 variables also, right? Because before we only talked about what?
2 variables.
And 2 equations, right? So when we dealt with 2 variables like 2x plus 3y equals 9, and then x minus y equals 4, or something like that, we graphed one of the lines and graphed another line, and the answer was the point of intersection, which is also called an ordered pair, right? Does everybody understand that? So when we have a system that looks like this, can we solve that by graphing?
No. Yes.
You can. Because here we had the x-axis and the y-axis, right? Here we have an x-axis, a y-axis, and a z-axis, which comes this way. Can we draw that? We can, if we're careful and use our imaginations a little bit. See, there's my x-axis, there's my y-axis, and here's my z-axis coming out of the page. See how it goes back through the page? So I have a dotted line right there, right? And if we have 3 variables, why do you think we write our answer?
I don't know.
Is it an ordered pair?
No.
Is it a point of intersection? Yes, right? It's a point of intersection because it's not 2 lines, is it? It's 3 planes. Here's a plane, here's a plane, here's a plane, right? Here's a plane that's there, there's a plane that's there, there's a plane that's there. If I could cut all the way through this with this one, I can't, so I'll just put it right there. Aren't they intersecting right down there? Yeah? Okay. Now, that's not all that can happen, right? They could all 3 be parallel. Is there a point of intersection then, if they're all parallel? What if 2 intersect like this, and then another one is parallel to that? Is there a point of intersection then? No. So there could be no solution, right? There could be all the solutions because they could intersect at a line. And there would be infinitely many solutions there because every point on that line would be a solution, right? Okay. My question, though, is how do we write our answer? It is a point of intersection. It's not an ordered pair, though, because this was like 2, 5. That's not the right answer for this system. I'm just saying it's like that, right? We had an x variable and a y variable, so we wrote it like that. How do you think we're going to write our answer today?
X, Y, Z.
X, Y, Z. So what's that called?
I don't know. Alphabetical order.
It is, but it has a name.
I don't know. I've never seen it before.
I know you haven't. That's why I'm teaching it to you today. It's not called an ordered pair. It's called an super close. It's called an ordered triple. Okay? It's an ordered triple because we still write it x, y, z. We still write it as like a point because it is a point of intersection, but it's a point of intersection at 3-dimensional space, so it's called an ordered triple. Okay? Now, I am not asking you to graph these. I'm not asking you to solve them by graphing. I'm not. I want you to know that it's possible because I want you to know how to write your answer. Okay? For the record, if this was like 2, 3, 4, for example, we would go right 2, up 3, and out 4. Does that make sense? Okay, that's how we would graph a system with 3 variables. Over 2, because our x-axis is 2, up 3, because our y-axis is 3, and then out 4. Like out, I would go 1, 2, 3, 4 if I could do it from the paper, but since I'm on 2-dimensional space trying to graph 3 dimensions, I would just come out this way along the z-axis. Okay? Again, I'm not asking you to do that. I'm making you aware of what it looks like so that when we do solve it, you remember you have to write the answer as order triple. Does everybody understand that? Okay, so then let's start with this problem right here. Okay, let's start with this problem. So please go ahead and get this written down. So this is the first system that we're talking about today. Okay? X plus 3y equals negative 17, 3x equals negative 6, and 4x minus 3y plus 6z equals 25. Okay? Now, what do you notice about the second equation? It's just x, right? Isn't that a good thing? Because what would happen if I divided both sides by 3? Right from here. What would we know? We would know x. And what is x? Negative 2. What do you think I should do with that negative 2? Plug it in where? To the top one. Why would I plug it into the top one? Because then you could find y. Okay? So x, which is negative 2, plus 3y equals negative 17. Well, to solve, I would add 2 to both sides, right? So I would get 3y equals negative 15. And how would I go about solving that? Divide both sides by 3. So what does y equal? Negative 5. So now what do you think I should do? I need to find z, right? That's the only one that I lack. And there's actually only one equation that even has a z, right? So what should I do with this last equation? Plug everything that I know into that last equation, right? So 4 times negative 2 minus 3 times negative 5 plus 6z equals 25. Well, 4 times negative 2 is negative 8. Negative 3 times negative 15 is positive, or sorry, negative 5 is positive 15. Plus 6z equals 25. Now we're just combining our like terms, right? Our constants. Very good. 7 plus 6z equals 25. Subtract 7 from both sides. Very good. 6z equals 18. If I divide both sides by 6, what do I know? It is 3. Am I done? I do have to write it as an ordered triple, right? Negative 2, negative 5, 3. Now, did I write it in order because that's the order that I solved it in? No, right? Why do I write it in this order? X, Y, Z. Okay, that's my ordered triple, X, Y, Z. Okay? Now, how did I just solve that system? What's the word that I used last time we met? The way that I solved that system? Remember last time there was 3 ways that we solved systems of equations? The first one was graphing. The second one, substitution. The third one was elimination. Which way did we just use? Substitution. That's the way we're solving today. It's with substitution. Okay? We talked about graphing, but I told you we're not going to do graphing, right? Today we're going to do substitution. Tomorrow we're going to do elimination. Okay? We need a little bit more time with each individual one of these because there's more variables to have to deal with. Does that make sense? Okay? Any questions on this first example? Okay. Let's do this example then. So I have 3y minus 6z equals negative 6. I have x minus y plus 4z equals 10. And I have 2x plus 2y minus z equals 12. What do you notice, first of all? Yeah, the first equation doesn't have an x, does it? Okay, is that going to be helpful for us? Yes? It eventually will be helpful for us, okay? So remember, when we're solving by substitution, we want to choose a variable to solve for, okay? Doesn't matter which variable we solve for. Not really, right? It doesn't matter really which variable we solve for. We can get the answer no matter which one we solve for, but are there some variables that are easier than others? Yes. In this particular problem, which one's the easiest to solve for? The second x, right? Well, it's really the first x because the first one doesn't have one. But it's this one, right? Are these also really easy to solve for? Yes, but they are negative. So if I don't have to choose them, I won't. But they would still be relatively easy to solve for, right? Because I'd have to just divide everything by a negative, yes? Okay? Now, let me make sure you understand that while this one is still a small number, it would not be a good idea to solve for this. Because if I was solving for this one, I'd have to divide everything by 4, right? If I divide everything by 4, what does that give me here, here, and here? A fraction, right? Now, guys, fractions are our friends. I'm not talking about they're your friends that you hang out with all the time. Okay? I'm saying they're the friends that you have in your life that you kind of put up with because you know you need them. Okay? We don't have to like hang out and go to dinner with the fractions, but we need to be able to put up with them. We need to be able to handle them. Okay? So there are friends like that, yes? Some of you just don't even like them, right? But I'll tell you this, you're going to have to learn to work with people you don't like. Okay? So, let's start here. Which one did you say we ought to solve for? The second x. Okay, so if we're solving for the second x, how do I get that one by itself? I add y. Can I do 2 steps at one time? Are you okay with that? Then can we also subtract 4z at the same time? If I do that, what I get is x equals 10 plus y minus 4z. Everybody okay with that? Now, if we're solving this by substitution, that implies that we're going to have to substitute it, right? Well, I solved for this x on purpose because this one's actually missing an x. If this one, well, it's like if that y was by itself, I probably would have solved for this x anyways because I already have one with a missing x. I need to be able to plug this one, substitute this one into the second equation, because when I do, what's going to happen? The x's are going to be gone, aren't they? Okay? So let's take what I know for x and substitute it right there. Okay? So 2 times 10 plus y minus 4z plus 2y minus z equals 12. So how do I solve this? What do I do? Right? Distribute. So 20 plus 2y minus 4z plus 2y minus z equals 12. Now, a minute ago you were okay with me doing 2 steps at one time, right? What did I do? Oh, good catch, good catch. 8. Very good catch. I did not do that on purpose, that was an accident. So can I use it as a teaching moment? Look how easy it is to mess up. I just did. Okay, so make sure you're focusing. Also, it helps when you're not talking while you're trying to do it, right? But that's kind of like my job, so thank you for catching that. I appreciate it. Okay, everybody okay so far? Okay. Up here, you are okay with 2 steps at one time, right? Do you think we could do 3 steps at one time? What are the 3 steps do you think that I want you to do?
Put the y's together.
Put the y's together. put the z's together, and can we also do this? Are you okay with that? Or is that too much?
No, that's good.
Okay. So what do I get for my y's? 4y. What do I get for my z's? Negative 9z. And then what do I get here? Negative 8. Everybody okay with that? Okay. So now I'm to a weird point, because now, what do I do now? Right? Because I didn't solve for anything, but what I have is an equation with two variables. But look what I have up here. Don't I have another equation with the exact same two variables? Did I mess up again? No? So if I just ignored all this work right here that I already did, nothing is wrong with it, now that you guys fixed it, right? Nothing is wrong with it. But if I just ignore all that work and just look at these two problems, isn't that exactly what I started with last time? The last time we talked about substitution? So what I do is I start over. I look at these two equations right here and solve for a variable. Okay? So it's like I solve for a variable. Oops, I forgot step 1. Don't panic. Step 2, solve for a variable. 3, simplify. And then 4, solve for a variable, right? Yes? What else could I say right here instead of simplify? I could say substitute, right? And then so here is substitute and simplify. So if I have this y, this z, this y, and this z, which one do you think would be the easiest to solve for? The top y, right? The top y. The top z would be okay, except that would give me a fraction right here, right, for my y's. But if I divide this by 3 and this by 3 and this by 3, am I going to get any fractions? That's why I don't want to try to solve for this y, because if I divide this by 4, I'm going to get a fraction, right? So if we solve for this y, I'm going to rewrite that down here, if you're okay with that. And now I'm going to solve for this y. How do I go about solving for this y? Add 6z. If I add 6z, I get 3y equals 6z minus 6. And what do I do with that y? Divide it by 3. In fact, I have to divide everything by 3, don't I? When I do that, I get y equals 2z minus 2. What did we do last time when we talked about substitution when I solved for a y? I substituted in, right? Remember I said substitute and simplify again? Where should I take this y? Should I go back to the beginning? Or should I go back to this equation I just found a minute ago? If I go back to this equation I found a minute ago and substitute y in here, what am I going to end up finding? Z, right? So I'm going to take this right here and plug it in right there. So I'm going to say 4 times what I know y equals, which is 2z minus 2 minus 9z equals negative 8. So let's distribute to get 8z minus 14. Oh, geez, I can't even multiply today, can I? I remember to multiply and then I just did it wrong. 8z minus 8 minus 9z equals negative 8. So now what do I need to do? Combine the z's. And can I go ahead and add 8 at the same time? So 8z and negative 9z is negative z equals 0. To solve for z, I divide by negative 1. So z is 0. That took a lot of work to find one z. Okay? If you're upset about that, I have Kleenex back here. What do I do with this z now? What should I do with it?
It's the last number in the...
It is, right? I could go ahead and start writing my answer, right? Up here, that's going to be a 0 right there for z, right? But I still have to find my x and my y, so is it okay if I bring my z right here? So y equals 2 times 0 minus 2. What is 2 times 0?
0.
Well, then what's 0 minus 2? Negative 2. So I could bring up my negative 2 and put it right there in my order triple. So what do I lack? X? How am I going to find x? Where do you think the best place to go is to find my x? Oh yeah, x equals, right? That makes the most sense, is to come up here for x equals. Because I need y and z, but don't I already have y and z? Okay, so x equals 10 plus negative 2 minus 4 times 0. Well, 10 plus negative 2 is 8, and then 8 minus 0? Just 8. Is that my answer?
Yes.
Can you be positive?
Yeah, you could plug it in.
Okay, I don't have an x, so negative 6 minus 0 is negative 6. Does negative 6 equal negative 6? Okay. So it works for that one, so it must be the answer, right? Oh, we got to check all of them, right? Okay, so 8 minus a negative 2, so plus 2, right? 8 plus 2 is 10. 10 plus 0? Does 10 equal 10? Okay, so that one works. 8 times 2 is 16. 16 minus 4. 12 minus 0? Does 12 equal 12? Then is this the right answer?
Yes.
Without a doubt, right? Okay? Any questions about that? Can we add to our steps? We said don't panic. We solved for a variable and then substituted it in. Then solve for a variable and substitute it in, and then what? Substitute everything? And then check. You okay with that?
Yes.
Does this have a lot of steps? Yes. Do we cry about that? No. Is there a lot of places to make mistakes? Yeah, if you hadn't caught my mistake up here, we would have done a lot of work for nothing, right? So, go slow. Okay? Let's do one more example. Okay, one more example. X minus 3y plus 6z equals 21. Then we have 3x plus 2y minus 5z equals negative 30. And then we have 2x minus 5y plus 2z equals negative 6. So what's the first thing I need to do? No, remember step 1 is not panic. What's step 2? Solve for a variable, right? Which variable do you think is the easiest to solve for? Which one? Very first x, right? So if we're solving for the very first x, what do I do?
Add 3y to...
Add 3y.
Subtract 6z.
Subtract 6z. So x is 21 plus 3y minus 6z. Okay, so far? Now that I have solved for that variable, what do I do with it?
Simplify or substitute.
So I simplified everything I could. Now where am I going to substitute it? This time, am I going to, like, do I have any missing variables? So I'm going to end up substituting this twice. One in the second equation, one in the third equation. Okay? So the steps that we wrote before was when one of the variables is missing, right? This time I'm going to have to substitute this exact thing twice. Once in the second equation, once in the third equation. In this case, second and third. It might be the first and third if what I solved for was in the second equation. Does that make sense? Okay? So we're going to take it one step at a time. I'm going to take this and substitute it into the second equation where there's an x. You ready? 3 times 21 plus 3y minus 6z, then plus 2y minus 5z equals negative 30. Does everybody see what I did? Okay. Now what? Distribute. 3 times 21, 63. 3 times 3, 9y, and then minus 18z, right? Plus 2y minus 5z equals negative 30. Are we still okay with doing 3 steps at one time? What are my 3 steps then? Combining my y's, combining my z's, and what's the last one?
Subtract 63.
Subtract 63 from both sides. Okay? So what I end up with then is what? When I combine my y's, I get 11y. When I combine my z's, I get 23z. When I combine my constants, I get negative 93. Okay, so far. This is where people panic and don't know what to do next.
Subtract.
I don't want to mess with this at all. I want to start over. I already substituted this into the second equation. What did I say a minute ago we needed to do also? Into the third equation, right? So start over. Substitute this into the third equation. 2 times 21 minus 3 or plus 3y minus 6z minus 5y plus 2z equals negative 6.
Distribute.
Everybody okay so far? Okay, so distribute here, here, here. So 42 plus 6y minus 12z minus 5y plus 2z equals negative 6.